Assalamu alaikum. Welcome to part 3a. At the end of this video, you will be able to be ready. Before you start, please prepare the following materials. Fundamental equations of the form tangent x equals to tangent alpha has the two solutions x equals to alpha plus 2k pi or x equals to pi plus alpha plus 2k pi, where k belongs to z. Hence, it is evident that tangent x equals to tangent alpha equivalent to x equals to alpha plus k pi. Let alpha be a given real number. Let m be a point on trigonometric circle such that am equals to alpha, the arc am. M prime is the symmetric of m with respect to origin. Here we have pi plus alpha. We have the equation tangent x equals to tangent alpha. Now we know that tangent alpha equals to at, since in the right triangle TAO we have tangent alpha equals to TA over AO, and we know that AO equals to 1, and T is the intersection between the tangent TT prime and OM. Now let the arc AN equals to x, then N will be on M. N is at M if and only if x equals to alpha plus 2k pi, and N is at M prime here if and only if x equals to pi plus alpha plus 2k pi. Take the first example. We want to solve in R minus pi over 2, since tangent x does not define on minus pi over 2 and pi over 2, we want to remove these 2 points from the real numbers. The equation tangent x equals to tangent pi over 3 has the solution, that is x equals to alpha plus k pi, and here we have alpha pi over 3, then x equals to pi over 3 plus k pi, where k belongs to z. Take the second example. Solve in the same domain of definition. Tangent x equals to tangent pi over 7, then 7x equals to pi over 7 plus k pi. Divide the equation by 7, then x equals to pi over 49 plus 1 over 7k pi, and k belongs to z. Application 1. Please read it carefully, pause the video and try to solve it. The equation tangent 3x has the solution 3x equals to 4 pi over 7 plus k pi. Divide the equation by 3, then x equals to 4 pi over 21 plus 1 over 3k pi. Application 2. Please pause the video, try to solve it. We have 2x equals to 3 pi over 5 plus k pi. Divide the equation by 2, then x equals to 3 over 10 pi plus 1 over 2k pi, and k belongs to z. Example 3. We want to solve in the open interval minus pi over 2 pi over 2 the equation tangent x equals to tangent 2 pi over 3. Now x equals to 2 pi over 3 plus k pi. We want to put the value of x between minus pi over 2 and pi over 2. We want to remove this term 2 pi over 3. Then divide this inequality by pi, then k will be between minus 7 over 6 and minus 1 over 6, hence k equals to minus 1. Thus x equals to singleton minus pi over 3 is the unique solution for the given equation in minus pi over 2 pi over 2. Now application 3, please read it carefully, try to solve it, pause the video please. We have the equation tangent x equals to tangent 2 pi over 5, then x equals to 2 pi over 5 plus k pi. We want to solve in the open interval minus pi over 2 pi over 2. Put the value of x between minus pi over 2 and pi over 2. Subtract this number 2 pi over 5. Now divide the inequality by pi. Then k will be between minus 9 over 10 and 1 over 10. hence k equals to 0. Put 0 here, then x equals to 2 pi over 5 is the unique solution for the given equation in minus pi over 2 pi over 2. Fundamental equations of the form sin x equals to a. It is evident that the equation sin x equals a does not admit a solution when a does not belong to minus 1, 1. Now take a in minus 1, 1. Then there exists an arc alpha belongs to minus pi over 2 pi over 2 such that a equals to sine alpha. This equation takes the form sin x equals to sine alpha. That means that a equals to sine alpha. Take an example to clarify the idea. We want to solve in R. Sin x equals to radical 3 over 2. We know that radical 3 over 2 equals to sine what? Sine pi over 3. Then sine x equals to sine pi over 3. Then x equals to pi over 3 plus 2k pi, or pi minus pi over 3 plus 2k pi, that is 2 pi over 3 plus 2k pi. We are interested just in the remarkable arcs minus 1 minus radical 3 over 2 minus radical 2 over 2 minus 1 over 2 0 1 over 2 radical 2 over 2 radical 3 over 2 and 1. As an application 4, please pause the video, try to solve it. Here we take sin x as a common factor, then sin x equals to 0 or sin x equals to 1. Then replace 0 by sin 0. Sin x equals to sin 0, then x equals to 0 plus 2k pi or pi plus 2k pi. If sin x equals to 0, then x equals to k pi. For sin x equals to 1, then replace 1 by sin pi over 2. X equals to pi over 2 plus 2k pi or pi minus pi over 2 plus 2k pi, that is pi over 2 plus 2k pi. Then if sin x equals to 1, x equals to pi over 2 plus 2k pi.